Okay. So I just created a worksheet really quickly, and I thought I would help you set up a couple of problems, and then I'll attach this worksheet into the email that I send y'all, and you can work it out. And I think that I'm just going to help you get them set up, and then maybe when I attach the worksheet, I'll send the answers as well. So when I look at this first one, I've got six that are absolute value equations, and then six that are absolute value inequalities. So when I look at the first one, remember I'm trying to get the absolute value symbols all by themselves. So I see that I have a -7 outside of the absolute value symbol. So that's -7 times the absolute value. So the first thing I'm going to do is divide both sides by -7. So the absolute value of 5x plus 10 equals, let's see, 105 divided by 7 is negative divided by negative is a positive 15 times. So now I've got my absolute value all by itself. So remember, I need to write two equations. My first one, 5x plus 10 equals 15. My second one, 5x plus 10 equals -15. Okay, so you go ahead and solve that. For number 2, I have the absolute value of 10v minus 5 all divided by 9. So the only way that I can get this all by itself is to undo the division, and the undo or the inverse of divide is to multiply. So I'm going to multiply both sides by 9, and that'll give me the absolute value of 10v minus 5 equals 3 times 9 is 27. So again, I get to write my two equations. The first one, 10v minus 5 equals 27. The second one, 10v minus 5 equals the opposite of 27, so -27. All right, when I look at example 3, I'm just going to subtract the 10 from both sides. Now I have my absolute value symbols all by themselves on one side of the equal sign. The absolute value of 2v minus 2 equals 12. I'm going to write my two equations. 2v minus 2 equals 12. And the second equation, 2v minus 2 equals the opposite of 12. Okay. For example number 4, I have subtraction and multiplication taking place. So the first thing I need to do is add 10 to both sides. That gives me 5 times the absolute value of n minus 5, and that equals 10. And then I need to get rid of that 5 times the absolute value. I do that by dividing. So n minus 5 and the absolute value symbols equals 2. So now I can write my two equations, right? My first one, n minus 5 equals 2. My second one, n minus 5 equals the opposite of 2. Okay. Example number 5 is tricky. So remember that when you have a negative outside of a parenthesis, this is no different, that really is a -1, right? So that minus sign is really actually a -1. Think of it as kind of almost being distributed, right? Although we can't go through the bar. The bars are like affirmed. You can't get anything in there. So the first thing that you're going to have to do is subtract your 6 from both sides. And when I do that, I have a -1 times the absolute value of 10 minus 5a equals -49, and -6 equal -55. And now I'm going to divide both sides by -1. So the absolute value of 10 minus 5a equals 55. So two equations. My first one, 10 minus 5a equals 55. And my second one, 10 minus 5a equals the opposite of 55. All right, this is the last equation, absolute value equation problem. So first thing, I'm going to add 10 to both sides. So I have 7 times the absolute value of 7 plus 2m equals 39 plus 10 is 49. This says 7 times the absolute value. The undo of multiply is divide. So I'm going to divide both sides by 7. So now I have the absolute value of 7 plus 2m equals 7. So now I can write my two equations. My first equation, 7 plus 2m equals 7. And my second equation, 7 plus 2m equals the opposite of 7. Okay, so work those out. And I'll post the answers for you when I put this video and send you your email. But I wanted to talk about setting up these, setting up the absolute value inequalities. So number 7, notice first of all, the absolute value symbol is already isolated, okay? And the symbol is less than, which is an and, right? Less than, which is an and. So first inequality, 8x minus 6 is less than 54. Second inequality, 8x minus 6 is greater than negative 54. Greater than negative 54. So when you solve these, remember when you solve these, you your graph needs to look something like this, right? The solutions need to go together in the middle. That's what an and does. The solutions go together in the middle. Okay. For number 8, when you get the absolute value all by itself, you're going to have to actually divide both sides by that negative 4 that's out front of the absolute value symbol. So remember what happens when you divide an inequality by a negative. You actually have to flip the inequality sign. We talked about that on the first video. Flip the inequality sign. Negative 84 divided by negative 4 is a positive 21. So you really have 3n minus 6 in absolute values is greater. So that's a great or. Remember I talked about that, a great or. So the two inequalities that you're going to write, you have 3n minus 6 is greater than 21. Or, this is an or, 3n minus 6 is less than negative or the opposite of 21. So when you graph an or, remember when you graph an or, you should have one solution that goes to the right and one solution that goes to the left. Okay. And I did not put it like, there's nothing special about these. Okay. Nothing funky or weird. So when I look at setting up number 9, I have 6 times the absolute value of 3x plus 10. Minus 7 is less than or equal to 35. The first thing I'm going to do is add 7 to both sides. 6 times the absolute value of 3x plus 10 is less than or equal to 42. Divide both sides by 6. So the absolute value of 3x plus 10 is less than or equal to 7. This is a less than. Think of this as an and, right? So remember when you graph this, your solution, your shading is going to go together in the middle. Your solution or your shading, ding, ding, dong, it is going to go together in the middle. Okay, like that. So your two equations, you're going to have two solutions, right? The first one, when you solve it, 3x plus 10 is less than or equal to 7. And the second one, 3x plus 10 is greater than or equal to negative 7. All right, next one, 7 times the absolute value of 3 plus 3x minus 2 is greater than or equal to 82. I am going to add 2 to both sides first. 7 times the absolute value of 3 plus 3x is greater than or equal to 84. I have to get rid of this 7 times the absolute value, so I'm going to divide both sides by 7. So the absolute value of 3 plus 3x is greater than or equal to 12. So your two, this is a great or than or equal to. So this is an or. Remember your graph. One's going to go shade this way. The other one's going to shade that way. So your two inequalities, your first one, 3 plus 3x is greater than 12. And your second, or 3 plus 3x is less than or equal to negative 12. Okay, let's look at number 11. So number 11, 5 plus 10 times the absolute value of 4 minus 9k is less than negative 45. So I'm going to subtract 5 from both sides. So that gives me 10 times the absolute value of 4 minus 9k is less than, let's see, negative 45 and negative 5 give me a negative 50. 10 times the absolute value, so the undo of multiply is divide. So I have the absolute value of 4 minus 9k is less than negative 5. So listen to what I said. This absolute value, the absolute value has a solution that is less than negative 5. Now remember, an absolute value has to end up with a positive number. So this is an example of no solution. So you can solve it. I'm going to show you what those two inequalities are going to look like. If you choose to solve this, this would be 4 minus 9k is less than negative 5, and 4 minus 9k is greater than the opposite of negative 5, which is positive 5. Remember that an and, right, when you graph an and, those would actually be open circles, but when you graph an and, those are supposed to go to the center. And what's going to happen when you solve this is you're going to see that one goes out this way and the other one goes out that way. They don't overlap. Your solutions don't overlap because there is no solution. Okay. All right. Last one. And then I need to go down to that basketball game. So 4 minus the absolute value of 7 minus x is less than negative 7. I'm first of all going to subtract 4 from both sides. So I have a negative outside of the absolute value of 7 minus x is less than, let's see, 7, negative 7 and negative 4 is negative 11. So this is a negative times. You have to undo that by dividing both sides by negative 1. When you divide by a negative, remember you have to flip your sign. So 7, the absolute value of 7 minus x is now greater than 11. So this is going to be an or. This is going to be an or. Your two equations are, or inequalities, sorry. 7 minus x is greater than 11, or 7 minus x is less than negative 11. Okay, so those are 6 examples of inequality, or sorry, of absolute